1. Soil creep. Soil creep is the slowest and least noticeable type of landslide, but over long periods it can cause significant damage. This gradual movement occurs when the upper layers of soil slowly shift downslope due to gravity. The movement is often imperceptible to the naked eye, just a few millimeters to centimeters per year. Creep is driven by repeated freeze-thaw cycles, where water in the soil freezes, expands, and lifts soil particles upward. When the ice melts, gravity pulls the particles slightly downward. Over time, these small shifts accumulate. Wet-dry cycles, thermal expansion, and biological activity, like burrowing animals or growing plant roots, can also contribute. You might notice soil creep by observing tilted fence posts, bent tree trunks, cracked walls, or sloping sidewalks on hillsides. Although not dangerous in a sudden, life-threatening way, soil creep is a major concern for infrastructure and foundation integrity, especially in regions with long-term moisture exposure or temperature fluctuations. 2. Earth flows. Earth flows are moderately fast-moving landslides composed of fine-grained materials, such as silty soils, clays, and fine sand. These landslides usually occur on slopes when the ground becomes saturated with water from heavy rainfall or snowmelt. Once water infiltrates the soil, it reduces internal friction, making the mass unstable and prone to flow. Unlike solid landslides, earth flows resemble a viscous, oozing substance slowly deforming and moving downslope. Depending on moisture content and slope steepness, earth flows can move at rates ranging from centimeters per hour to several meters per minute. They often originate in areas with deep soil layers and vegetated slopes. As the mass moves, it can bulge at the toe, lower end, and leave behind a scarp, a steep cut at the top. Roads, pipelines, and houses in the flow's path are often damaged by the uneven ground movement. 3. Debris flows. Debris flows are rapid, highly destructive landslides made of a chaotic mix of soil, rocks, vegetation, and even man-made debris like cars or building fragments. They are most commonly triggered by intense rainfall, especially following wildfires that burn away vegetation and expose loose soil. What makes debris flows particularly dangerous is their speed and density. These flows can travel at 35 miles per hour or faster, often following stream channels or canyons. The slurry's consistency is similar to wet concrete, allowing it to push through forests, neighborhoods, and infrastructure. In 2018, a series of deadly debris flows struck Montecito, California, following wildfires and heavy rain. Entire homes were buried, and over 20 people lost their lives. This tragedy highlights how quickly these landslides can go from a minor threat to a full-blown catastrophe. 4. Mud flows. Mud flows are closely related to debris flows but consist of finer particles, mostly silt and clay, with higher water content. This makes them more fluid and capable of traveling long distances, sometimes dozens of kilometers from the point of origin. Mud flows typically form on steep, barren slopes after a short but intense period of rainfall. They can also originate in volcanic regions, deserts, and dry mountainous areas where water absorption is low. The flow can pick up speed as it gathers more water and material, gaining destructive power as it travels. A major mud flow disaster occurred in Venezuela in 1999, when torrential rains triggered catastrophic flows down steep mountain slopes. Entire towns were engulfed, and over 30,000 people were killed. This remains one of the deadliest natural disasters in South American history. 5. Rockfalls. Rockfalls are one of the most sudden and visually dramatic types of landslides. They involve detached blocks or fragments of rock, breaking off steep cliffs or slopes and falling freely or bouncing down due to gravity. Common triggers include freeze-thaw cycles, where water enters cracks in rocks, freezes, and expands, eventually causing the rock to fracture. Other causes include earthquakes, weathering, erosion, or even vegetation growth in rock joints. Rockfalls are extremely dangerous because they happen with little or no warning. They can strike roads, railways, and hiking trails in mountainous areas, causing fatalities and major disruptions. In some areas, netting or fencing is installed to catch falling rocks and protect human life. 6. Rock slides. Rock slides occur when a large mass of rock breaks away and slides along a pre-existing surface. such as a bedding plane, fault, or joint system. Unlike rockfalls, which are free-falling, rock slides involve a more cohesive block of material that moves relatively intact. Rock slides can be triggered by intense rainfall, earthquakes, volcanic activity, or construction activities that weaken the slope base. These events can happen suddenly or develop slowly over days or weeks as cracks widen and instability increases. One of the most devastating rock slides in history occurred in 1970 in Peru, when a massive rock and ice avalanche from Mount Huascaran buried the town of Yungay, killing more than 20,000 people. This tragedy shows the scale and unpredictability of large rock slides. 7. Slumps. A slump is a type of landslide where a coherent block of earth slides down a slope along a concave, curved surface. Unlike translational slides, which move in a straight line, slumps involve rotational movement. The upper part of the slump sinks downward while the lower part bulges outward. Slumps are usually caused by water saturation, erosion at the slope base, or construction that undercuts a hillside. They're common along riverbanks, coastal bluffs, and road cuts where steep, unsupported slopes exist. While slumps move more slowly than debris flows or rockfalls, they can cause significant structural damage, including road deformation, tilted homes, and broken pipelines. In some cases, slumps evolve into faster-moving earth flows or debris flows. 8. Translational slides. Translational slides involve the downward movement of soil or rock along a flat or slightly inclined surface, such as a bedding plane, joint, or man-made cut. The movement is usually planar, meaning the mass slides straight down without rotating. These slides are typically triggered by heavy rainfall, deforestation, overloading at the slope crest, or earthquakes. They can be extremely rapid and cover large areas, making them especially hazardous for towns built on unstable slopes. Translational slides are more common in areas with layered sedimentary rock or where human modification has altered the natural slope. If the slip surface is lubricated by water, entire sections of land can break off and travel downslope in minutes, taking roads, homes, and trees with them. 9. Lahars, volcanic mudflows. Lahars are volcanic mudflows made of a mixture of water, ash, rock, and debris. They are triggered by volcanic eruptions that rapidly melt snow or glaciers, or by intense rainfall on volcanic ash-covered slopes. The resulting slurry flows rapidly down valleys and river channels. Lahars can reach speeds of up to 60 kilometers per hour, 37 miles per hour, and travel dozens of kilometers, destroying everything in their path. They are especially lethal because they often strike without warning and are associated with volcanic eruptions, which already bring chaos. The 1985 eruption of Nevado del Ruiz in Colombia unleashed a massive lahar that buried the town of Armero, killing more than 23,000 people. This remains one of the deadliest volcanic disasters in history. 10th. Submarine landslides. Submarine landslides happen underwater, usually on continental slopes or near submarine volcanoes. These massive events can involve billions of tons of sediment and are often triggered by earthquakes, undersea volcanic eruptions, or the collapse of gas hydrate deposits. Though they occur deep below the ocean's surface, submarine landslides are of grave concern because they can generate powerful tsunamis that threaten coastal communities thousands of miles away. One of the largest known events was the Storegga slide, which happened off the coast of Norway about 8,000 years ago. This underwater landslide triggered a tsunami that inundated parts of Scotland and Northern Europe, showing just how far-reaching the impact can be. If you learned something new today, don't forget to like, share, and subscribe for more epic Earth science breakdowns. And let us know in the comments which landslide surprised you the most. Thanks for watching, and stay safe on those slopes.